So you have a big shaft on which there are these small turbine blades which are mounted, and they are rotating at thousands of RPM, and at such high RPM and such high temperatures above 1000 degrees Celsius, they would be subjected to loading. So there is centrifugal force acting on each of the blades, and there are hot gases passing over it. The scientists realize that the failure of the blade that happens because of high temperature deformation is what is called as creep. Initially, engine manufacturers might have started with some material, but then eventually they came to nickel alloys. And then when they started making nickel alloys, they realized that if it has a polycrystalline microstructure, polycrystalline means, let's say if you're looking at a microstructure, you have lots of grain, maybe hundreds of grains. A grain comprises of all of the atoms which are nicely arranged in one given pattern. So they have one particular crystallographic orientation. So they realized the creep failure happens sooner if you have a polycrystalline microstructure. They realize that most of the loading is happening radially. If, let's say, we do not have any grains which are perpendicular to it, that would also improve the life. Then they evolved the process to making columnar microstructure, where you will have grains, but most of those grains would be single from bottom till the top. To make it a columnar grain, you cannot do it using a traditional casting process. You use something called as abridgment